mate.
What's up, mate? I wanted to ask you about graph because I didn't understand about that.
You're in the right place, my friend. I can explain what you want.
Oh, thank you so much, you're really my best buddy.
First, you have to know about graph in mathematics, and more specifically in graph theory. A graph is a structure amounting to a set of objects in which some pairs of the objects are in some sense related. The objects correspond to mathematical abstractions called vertices, also called nodes or points, and each of the related pairs of vertices is called an edge, also called link or line. Typically, a graph is depicted in diagrammatic form as a set of dots or circles for the vertices, joined by lines or curves for the edges. Graphs are one of the objects of study in discrete mathematics. The edges may be directed or undirected. For example, if the vertices represent people at a party, and there is an edge between two people if they shake hands, then this graph is undirected because any person A can shake hands with a person B only if B also shakes hands with A. In contrast, if any edge from a person A to a person B corresponds to A owes money to B, then this graph is directed, because owing money is not necessarily reciprocated. The former type of graph is called an undirected graph while the latter type of graph is called a directed graph.
Wow, you know a lot about the graph. But I have last question, can you explain to me about book embedding of graph?
Sure, my friend. In graph theory, a book embedding is a generalization of planar embedding of a graph to embeddings into a book, a collection of half-planes all having the same line as their boundary. Usually, the vertices of the graph are required to lie on this boundary line, called the spine, and the edges are required to stay within a single half-plane. The book thickness of a graph is the smallest possible number of half-planes for any book embedding of the graph. Book thickness is also called page number, stack number or fixed outer thickness. Book embeddings have also been used to define several other graph invariants including the page width and book crossing number. The graphs with book thickness 1 are the outerplanar graphs. The graphs with book thickness at most 2 are the subhamiltonian graphs, which are always planar. More generally, every planar graph has book thickness at most 4. All minor closed graph families, and in particular the graphs with bounded tree width or bounded genus, also have bounded book thickness. It is NP hard to determine the exact book thickness of a given graph with or without knowing a fixed vertex ordering along the spine of the book. One of the original motivations for studying book embeddings involved applications in VLSI design, in which the vertices of a book embedding represent components of a circuit and the wires represent connections between them. Book embedding also has applications in graph drawing, where two of the standard visualization styles for graphs, arc diagrams and circular layouts, can be constructed using book embeddings. As shown in the first figure, the book thickness of the complete graph K5 is 3. As a non-planar graph, its book thickness is greater than 2, but a book embedding with 3 pages exists. More generally, the book thickness of every complete graph with n4 vertices is exactly. This result also gives an upper bound on the maximum possible book thickness of any n-vertex graph. 10. The 2-page crossing number of the complete graph Kn is. Matching a still unproven conjecture of Anthony Hill on what the unrestricted crossing number of this graph should be. That is, if Hill's conjecture is correct, then the drawing of this graph that minimizes the number of crossings is a 2-page drawing. The book thickness of the complete bipartite graph Ka, B is at most min A, B. To construct a drawing with this book thickness, for each vertex on the smaller side of the bipartition, one can place the edges incident with that vertex on their own page. For the Turing graph TKR, a complete multipartite graph KK, formed from R independent sets of K vertices per independent set, with an edge between every 2 vertices from different independent sets, the book thickness T is sandwiched between. The book thickness of binary de Bruijn graphs, shuffle exchange graphs, and cube-connected cycles, when these graphs are large enough to be non-planar, is exactly 3.
Cool, you really great Harry, you should become a lecturer.
Oh thanks man.
Thanks for the information bro.